Some more terminology still related to this idea. A matrix is in reduced row echelon form, so RREF, and actually that acronym is very standard and you're going to find it also in your calculator. We'll talk about that in class. If two things happen. Well, first of all entries above and below the leading coefficients have to be 0. So not only we're going to be happy with the numbers below the leading coefficients being 0, but we're going to expect also the numbers above the leading coefficients to be 0. But that's not enough. What we want is that all those leading coefficients have to be 1s. Okay? So if there is any leading coefficient in any row, it has to be equal to 1. So again, let's look at this matrix. This is, as we saw earlier, it is in row echelon form, but not in reduced row echelon form. Okay. For instance, there is that number 5, which is sitting on top of the 7 in the 4th row, which is a leading coefficient. So we need to get rid of that one. So if we can do something to change that 5 into a 0, now we're talking about a not yet row echelon form. Remember, there is the other condition. That 7 is the leading coefficient in the 2nd row. Leading coefficients are not supposed to be different from 1. So we'll need some other operation, some other way of changing that 7 into a 1. By the way in which we're going to make those changes in order to change the leading coefficients in an appropriate way is by using elementary row operations. Okay, so in class we're going to look at how to make those changes in different situations, easier done through examples than anything else. But if we can change that 7, that 3, and that other 7, those 3 leading coefficients which are not 1s, into 1s, then we're going to be fine. So once we do all that, we come up with a matrix which is in reduced row echelon form. Now at this point you may be wondering, how about that 9 and that 4 which are actually in this position right here? Well, these two numbers are perfectly fine because the 4 is not a leading coefficient. Remember, the constraints are only on the leading coefficients. When we are in columns which don't have a leading coefficient, like that 4th column, that's okay. The numbers can be whatever they want to be. Okay, so those two numbers are perfectly fine wherever they are. And of course, the same applies to the 3 numbers which are in the column of constants. Still some more terminology related with this process. So the process of changing a matrix to an equivalent matrix, meaning using elementary row operations in row echelon form, is called Gaussian elimination. So if we start from our matrix and we do enough row operations so as to change it to row echelon form, we say we've done Gaussian elimination. If we keep going from there, and in fact the technique is to go first to Gaussian form, then to Gauss Jordan form, or first to REF, then to RREF, then of course if we do the whole thing, then we say that the process is called the process of Gauss Jordan elimination. Okay? Both methods again use elementary row operations only. Okay, and so remember, those are the only rows that we need. And in fact, because of the fact that what we do is we use those row operations in order to change a matrix to REF, or even better RREF, that method always allows us to solve the system. So what is the general strategy to change a general augmented matrix coming from a linear system into its RREF form and therefore get the solution? Okay, so of course we're going to use row operations, and we're going to use them and we're going to choose them. Remember, at every step we have to choose a row operation. We're going to choose them by aiming for one of these goals. One of the things we want to do is get zeros in the lower left corner first. That's what's going to allow us to get the REF form. So that's the first aim that we're going to look for. Then after we've done that, we're trying to get zeros above the leading coefficients. Okay, once we get all the leading coefficients, we try to change all the numbers above the leading coefficients so that they become 0. Then we're gonna, at the end, we're gonna try and get ones in leading positions when possible. Okay, at the end we're gonna try and actually get them all to be equal to 0 if we want the RREF form. Okay. The other thing also is that we may want to get small numbers, play with small numbers if at all possible, and we may want to also avoid fractions if possible. Okay. By the way, notice that when getting ones in the leading position, I'm saying when possible, meaning that it has to be done sooner or later. The sooner, sometimes, the better. Not always, but certainly at some point we want to do that. While getting small numbers and fractions, only if possible. Sometimes it may not be possible, it may not be advisable. Notice that these first three steps are structural steps. In other words, those are steps that we have to do in order to get to the desired RREF form. However, these last two are convenient steps. If you're comfortable playing with or working with large numbers or with fractions, you don't have to use them. While the first three steps, you absolutely have to go through them.